Hello everyone, welcome to this another video on the linked list. So in the last video we discussed how to implement a linked list using Java, and we did add elements to the list and we were able to print those elements from the list. So if you have not watched the previous video, I will give the link in the description. Please go through that one and then you can come back to this video. In today's video, we are going to discuss about how to remove an element from a linked list. So in the last one, we discussed how to add element, how to print the list. So let's quickly go through. So we did some sample data. So we created a new linked list. We added three elements, then we printed the list, then we add another element, then printed the list again. So I'm just going to run it quickly and see. So you see in the first list we have 1 4 6, then in the next second list we added 10, so we have 1 4 6 10. Simple. So now what we want to do in today is we want to remove an element from the linked list actually. So let's so I'm going to just go ahead and just going to create a method here. So for removing linked list, so this method, you delete the element, then you return back the same linked list back actually. So let's say, and if you want to remove an element from the linked list, so this method will take the linked list first as the argument. So I'm going to say, let's say this is my linked list, so you're going to pass this list, and then you're going to pass the element which you want to remove. So in this case I'm passing this data which could have any value, and the return on this one will be just so output return, then we add logic. So let's see, so we don't have any syntax errors here, so we're going to put the logic here actually. And as I discussed in my previous videos, when you are given a linked list, you always have access to the head of the linked list. So let me just quickly go here. So this is a sample linked list I took here. So you have a linked list, it has three elements, three, and this node contains the address to the next one, and the next node has 5. This will contain next to address to the next node, which is now 7. So you see this linked list has three elements, and you always need access or reference to the head, otherwise you don't know about the linked list because you need some kind of a reference, and the reference is always to the head of the linked list. So if you want to delete an element from the linked list, what could happen? You have like couple of, there are 2 or 3 scenarios. Let's say you want to remove the first element. Let's say I'm going to go back here, and let's say in the data you pass number 3. So first case is the element which you want to remove is the very first element. That's one scenario. Other scenario is, let's say you want to remove 5 or 7. So in that case, what you have to do is you have to start navigating the list from here and go like this way. First element check, if not go to the next one, and if not then go to the next one. So let's say you choose 5, so you're going to remove this element. And the third scenario is, let's say you want to remove element which has the value 9. So you start here, you check 3, no, 5, no, 7, no. So that means 9 is not found. So you don't do anything really, you just scan through the list and return the same list back again. So let's take the first example. Let's say you pass 3, and you pass the very first element to be deleted from the linked list. So what's the scenario for that one? So let's see, we want to check that thing very first. So you have the access to the linked list. So this is a linked list, and so this list, and if we say list dot head, so this will return the pointer to the head node. So we just want to maybe make a copy of this one is separate, so that we don't want to really deal with the head. So let's say current node equal to this. So we got, we just make a copy of this head. So this is now really pointing to the head of the linked list. And let's say the element which we want to delete is the first element. So what you can do here is you can do a check here actually. if current node not equal to null and cur node dot data equal to data. So basically whatever the value of the first node's data equal to this value which you pass. So it means this is the first element of the list which you want to really delete. So if you want to delete this month, so if think of it like this, in this case, if you want to delete this one, so let's say, I'm going to just choose a different. If you want to delete this guy here, what do you have to do really? If you want to delete this one, let's say you want to remove this from the whole thing. So the only thing really you have to do is you have to reset this head, because that's the only thing really, head. And where you want to go the head, so head should really point to this guy now here, next one here. And this next one, how do we know what's the address of this one? Next one. So the next one is really this node, whatever the address of this node, this is right now current node. So current node dot next, that's really pointing this one, and that should go to your head actually. So what we have to do is we have to say list dot head is equal to current node dot next. Okay, so we changed the pointer, so that's the only thing. So what we did is, this is the current node and this is the current node dot next, this is the current node next, and this is really pointing to this guy here, next node. So what we did, we took this address and we put it in the head, and so it means this got disconnected already, now it's out of the picture now. So this is pointing to this one, so that's done actually, and it means now the list dot head will be pointing to the second node really. So and you can return it. So this is one scenario, or you can actually, you don't have to really go all the way, you can just return here, because first element deleted, you can return here. Okay, now we go to the second scenario, and the second scenario is like this. So let's say, let me see if I can do, let me remove this stuff from here. Okay, so in the second scenario, the situation is like this. Let's say user want to delete this element here, they want to remove 5. What we have to do, so we always have the head, so we start from the head navigation and we compare this, whatever the user pass. Let's say they want to delete 5 but 3 not equal to 5, so we skip this element, we go to the next element here, we reach this element and say, oh yeah, this is the element we want to really delete. So if this is the element which we want to really delete, and let's say if you want to delete this element, what we have to do, the value of this element, we have to really, this, instead of pointing it here, we have to point it to the next one. But the problem is, when we are navigating, we are at this element and we don't have a reference to the previous element. So it means we have to maintain a reference to the previous element, because when we are going to delete, we have to use the reference of previous element and point it really to this element actually. So it means when we are navigating to this list, we have to always keep track of the previous element too. So right now if we are on this element, we also have to keep a reference to this one, because then we have to take the reference of this one and really skip this element and point it to here actually. So let's see how we can do it through the code actually. So what we have to do here is now, so so let's say if we didn't go into this case, so it means we have to again do a while loop now, because we have to keep scanning through the list. So we are saying again cur node, again we check if it's not null, and node dot data not equal to data. So we're saying if it's not equal to data, then we keep going further in the list. So going further mean cur node will become now cur node dot next. but we also have to keep a track of the previous node. So as we mentioned, we need the previous node too. So I'm going to create a new node here called preb node. Well, so just a preb equal to null in the beginning here. And when we are scanning here, so always yeah, so before I assign go to the next node, I have to say preb will become the current node will become the preb, and then the current node will become the next node. So basically I'm just trying to, the part of the current node I'm putting that in the previous, but the current node then I'm extending to the going to the next one. So really, you know, what I'm trying to do is current node was here. No, when current node was at this point, I want to, no, current node was here, so I want to keep this here, but now the current node becomes here. So I want to keep track of the previous one here actually. So let's say, okay, so this is another scenario. So if you have gone through this list and if we exit out of this list, so it means current node dot data not equal to data. So it means it has not found the data, it will keep going. But as soon as it found the data, let's say it found the 5 which we want to delete here, it found the 5 which we want to delete here, then what we have to do is, it means the current node which we want to delete and the current node. So if the current node is not null, it should mean we found the node. This is the node which we really, if it's not null, so it means that's the node which we really want to delete actually. So what we have to do is, now you want to delete this current node, so what happen is we to the previous dot next, now previous dot next we have to assign the current just current node dot next. So what we did is, because we find the node to delete, so we found this node is to be deleted. So it means whatever the next of this is a current node. So whatever the next of this one means this is the node, this is the, so we have to assign that to the previous dot next here actually. So it means previous was pointing to, so now we kind of disconnect this from the loop, we go straight from here to here. So it will, this way to delete this particular node. So we did this one. And another case is, let's say if the we have reached the end of the list and if the current node is was null. Oh, so this means we have reached the end of the list and there's nothing to really remove. So, you know, we can just say, you know, I don't know, element not found. Okay, so we can, here we can really say is yeah, at this point the element was deleted actually in this way, because if you come into this loop, so this element was deleted from the list. And here we really did is first element was removed actually, really. That's the logic. First element was removed. Yeah, and I think that's all we need. So we can remove items, so we can go into the main method now. So if you remember this one, let's say, yeah, we have 10 here. So let's say you want to remove 6 now from the list. So I'm going to say my list dot remove, and my list you pass, and you say I want to pass 6 here, and after pass 6 I want to really print the list and make sure it's printed. So let's see, let's move this one. Okay, so 146, next list is 14610, element was deleted from the list, so now we have the list only 1410 left actually. So then, you know, it means let me put little printer statement so that, you know, it just prints on the next new line, but it just should not change. So yeah, so you see element was deleted from the list, so it's deleted the, and we have 1410. Let's do one more thing. Let's say let's try to remove the, let's put some other element like, you know, which is not in the list, so I will put like 20 here. I put 20, and we know the 20 is not in the list, so it says 146, 6 was removed, then next element was not found there, so the list is still same actually. So let's say I want to remove, let's say first element from the list is 1. So okay, yeah, so 1 4 10 is the list. Now first element was removed, so it means now we have the list only 4 10 left. First was removed. So I hope you like this video. So please watch my previous video first, then you watch this video for the deletion, and in the subsequent videos we'll go through some other implementations of queues, stacks, and other different kind of data structures. And I hope you like this video. Please consider subscribing to the channel and like the video. Thank you, and see you in the next video.